Hey everybody, I was asked to give a quick example of using the Gauss-Jordan elimination method to solve a system. This is one from one of the problems in the book, in the My Open Math system. So the system of equations given here, 3x plus y is 14, and 2x plus y equals 12. Now, we could solve that graphically, right? Just graph both lines and see where they intersect. But let's follow the steps that they've asked us to do. The first line says to change the system of equations to a matrix. And just notice that the system of equations is written in the kind of nice way so that it's easy enough to do that. But in both lines, the x stuff happens first, then you see y's, then the equal signs, and then numbers on the right-hand side. So this system should be 3, 1, 14 in the first row, and in the second row it's 2, 1, and 12. So that part's almost trivial, but let's just double check. There's a, well, I'm not sure if the student version has this, but as the teacher, you get this little button that you can check your work. And sure enough, I've got the same things as what that says. Then the next thing it asks us to do is to get a 1 in row 1, column 1. That is the 1, 1 position. If that's not a 1, then, make a change so that it becomes a 1. So it's not a 1. I'm switching to the doc cam here so we can actually work a little more facilely. One super easy way to do this would be to row scale. Change the 1 there to a, change the 3 there to a 1 by scaling row 1 by a factor of 1/3. But then from now on, if I did that, I'd have fractions involving 3 and everything. And so I'm going to pick a different route. And this is something you're free to do, right? You can, if you think the arithmetic will work out simpler, you can use other approaches. So the approach I think would be smarter is to take row 1 and do a row replacement operation. That is, row 1 becomes row 1 minus row 2. Has the same effect of getting a 1 in the 1, 1 position there, but well, no fractions, right? So if I do that, let's just notice that row 2 is unaffected, so it'll be 2, 1, 12 still. And then row 1, well, by design, we'll get a 1 in that position. Yeah. What else? We were taking the row 1 and subtracting the entry in row 2, so it's 1 minus 1, that's 0. And then same thing in this column, the 14 minus 12, which is 2. So that's our first step. Let me jump back to the My Open Math system and using the wrong computer's mouse. Okay, see if we've got it right so far. What I had in there was a 1, a 0, and a 2. And the second row was unchanged, right? It was still 2, 1, and 12. So I'll double check our answer. Oh, look, they did it the other way, and they're getting all kinds of fractions now. I don't know. I'm not sure whether they'll mark me wrong or right. I guess I gotta hit yay, submit, and see whether it likes that much of it. Okay, well, in my opinion, that's a flaw in the problem. If they mean for us to do this thing by this get this 1 here by row scaling, then they ought to let us know that. If we were to do it by scaling, that's a 1, this is a 1/3, and this is a 14/3. And let's see if it likes that version of it. Yeah, now it's outlined in green now. Well, I would argue that that's a computer being a computer, right? Being a little too literal about it. We should be able to take a different method, approach it that way. Well, okay. let's let's not complain too much. Get a 0 in row 2, column 1. If there's already a 0 there, retype the matrix. What position are they talking about? Row 2, column 1. That's here. It's currently a 2. To turn that into a 0, okay, I'm gonna go back to the .cam and sorry, we did stick with this method, changing doing the scaling and not that one. That makes this a 1/3 and this 14/3. I guess I'll write those neater in the next position. Oh, well, okay. Given that those are the entries we want now, what would we do to get the 0 and where this 2 is? That would be row replacement this time. Row 2 would become row 2 minus 2 of row 1. Okay. And row 1 won't change. We're only affecting row 2 of that operation. This will become a 0 for sure. What about the position right here? It's 1 minus 2 of those. 1 minus 2/3 or 1/3. Then 12 minus 2 of those. Oh, geez. 12 minus 28/3. I really don't like having to do this, but here we go. I'm going to jump over to GeoGebra because I just don't want to mess up the arithmetic there. 12 minus 2 times 14/3. 8/3. Okay, fine. Let's continue with my work. This is an 8/3. So now I should be able to put it into the computer and double check that we're making my open math system happy. Okay. Well, we don't need that. We need to get back to here. All right. So the things that I wrote down by hand a minute ago on the .cam, row 1. Well, yeah, that's right. This first row is unchanged in this operation. The next row has a 0, a 1/3, and 8/3 in it. Cool. And now if I hit submit, of course you can't do this checking your work intermittently in between because you only get so many tries before it marks you wrong, but see how it liked what I did there so far. Well, finally, or not finally, there's one more step after this, but then the next operation, it asks us to get a 1 in row 2, column 2. This is the second row, second column. It's where there's a 1/3 currently. And let's, again, go back to the thing where we can work with a pen and paper to do that. Since the last time they forced us to do row scaling to do this, I'm imagining they want us to do row scaling here too. Oh yeah. Well, if I did a row replacement operation, I'd mess up the 0 that I just created. So that would be a bad idea anyway. All right, so the scale factor, well, it's easy. It's just 3 times everything by 3. And that makes, let's write it down. Row 2 becomes 3 times row 2. And what's the deal? Well, okay, yeah, row 1 unchanged. Just take away the dividing by 3s in row 2, so that's a 1, and that's an 8. Cool. All right, so let's see. 1 divided by 3, 14 divided by 3, because again, row 1 doesn't get changed in the operation I just was doing. we were scaling the second row by a factor of 3, making that position to be a 1, and the final position in the third column is an 8 now. All right, and we can hit this little button to just check. I guess 4.666 forever is the same as 14 thirds. Sounds about right. 12, yeah, 4 and 2 thirds. Shoot, can't talk. 4 and 2 thirds there. But 0, 1, 8 is the things that change. So that's where we got that. Okay, last thing is get a 0 in row 1, column 2. That's the position that currently has 1/3 or 0.3 repeating forever in it. Row 2 is not going to change, so let's go ahead and just put that guy's entries in there. But what's going to happen to this row? Now, if you try to use row scaling, for instance, you'd have to multiply by 0. You'd have to turn that 1/3 into a 0. That's not going to be smart. If I do a row replacement, it's sort of interesting that adding some multiple of the second row to the first row is not going to mess up the 1 that's currently there in the 1, 1 position, because what's underneath of it in row 2 is a 0, and any multiple of 0 added to a 1 is just still going to be a 1. So that position can't get changed by a row replacement. What I'm trying to do is make this position be a 0. So there's honestly only one number that we have to figure out. And to figure that out, we have to decide what exactly was the row replacement operation. All right. What am I going to do? What multiple of row 2 could I add to row 1 in order to fix things, to make that position be a 0? Row 1 gets replaced by itself plus or minus, well, look, it's going to be minus 1/3 of what's in row 2. What do you see why it has to be that we want to subtract 1/3 from 1/3 in order to get a 0? What's here currently is a 1. So 1/3 of that will get us the right number so that we, okay, great. And so if I do that, I've already sort of told you on the other screen what the output is going to be. We have row 2 unchanged. We know this is going to be a 1 and that is going to be a 0. So the big deal is what happens to here. We'll have 14 thirds minus 8 thirds. Let me do the row replacement operation I indicated. 14 minus 8 is 7. 7 thirds. Wait, am I doing that right? 14 minus 8 is 6. 6 thirds. Oh, wait a minute. I think I can simplify 6 thirds without having to turn to a calculator. That's 2. All right, so let me pop back to my open math, and we'll see if that actually is correct. Oh, and then, right, it's asking us for an answer. The answer is the x-coordinate is 2, the y-coordinate is 8. Because that's what that says. You read this matrix as an equation now. The first line is just 1 times x plus 0 times y equals 2. In other words, x is 2. And the second line is, similarly, it's y is 8. So it did notice the help on that it told us to enter a point. So I knew to put that in parentheses with a comma between the things. Did it like everything now? Cool, I got it. Let me point out, if here you have the computer to tell you, yeah, you got it correct. I guess this is also using a computer to tell you, yeah, you got it correct. But the other approach one could take here in using some technological aid is to make yourself up a matrix of the form we just had. The equations, the numbers in the coefficients were 3 and 1, and then it was a 14 in the right-hand side. So there's your first row. The second row was 2 and 1 and 12, if memory serves. Is that really the same matrix we had here? Well, in GeoGebra, you can just ask for the reduced row echelon form. What? of the matrix. I call it A, so reduced row echelon form of A. Yep, that's the same thing we got by doing the Gauss-Jordan elimination stuff by hand. Of course, this is a good bit quicker, but I would say in this particular case, it's just a chance to use some technology to check yourself. Did you go through the steps correctly? All right. Well, I hope that was helpful. Have a great day.